The title of this presentation is How We Can Harness Heat Energy to Power the World by Charles Sturgill. Energy. Energy is something that we've been using in our daily lives for many years now. It's been used for generations and for decades to power our lives and our planet. Energy is something that helps us to evolve as a species. We depend greatly on energy, and it is something that we use more and more each year. As time goes on, we're always looking to find new ways to harness energy and new types of energy to get us along our way. Energy is something that we need so that we can keep going. It's beneficial and supporting in making new advancements in technology as well as medicine. But each year, we tend to use more and more energy, and we burn more and more resources. It's vital for us to be able to find a certain resource that we can use without depleting all of the natural resources that we have. One energy source that we might be able to do this with is heat energy, if we can learn to harness it and to use it to power the world we live in. Energy continued. We have made many advancements with energy over the years. We have used water mills and waterfalls to power specific plants and mills. Years ago, we used to take water mills and they would convert kinetic energy from flowing water to kinetic energy that would then grind grain for food. Also, we've made multiple advancements in our hydroelectric power plants that use turbines that convert kinetic energy from waterfalls into mechanical energy that can be later converted into stored electrical energy. Energy loss is something we have always dealt with when it comes to the different processes involved. Some energies can be categorized as high-grade energy and others as low-grade energy. To explain this further, there are different types of energy that can be converted or stored, and when that happens, a lot of times there's energy that is lost. Some of the different conversion types and storage processes that we use for energy have different amounts of energy loss associated with them. Some have less loss than others. The ones that have the least amount of energy loss are called high-grade energy, and that's like electricity, where when it's being converted or stored, there's a small amount of loss. Then there are other ones that are low-grade energy, and those are thermal energy, which is heat. Thermal energy. Thermal energy is usually considered low-grade energy. Student scientists from Northwestern University are working on a device to harness thermal energy. The devices can potentially take wasted heat energy to power electronic devices. Thermal energy is something that we give off, like when we touch something, that's heat that's being transferred, which is also energy that is lost or wasted. The idea of harnessing heat energy that can be lost is basically taking low-grade thermal energy and converting it back into high-grade energy where there's little lost. Grad students at Northwestern University have been working with supercomputers and other scientists to develop certain thermoelectric powered devices. Their project is going a little bit slow right now, but the general idea of it is to convert wasted energy that comes from our body heat to potentially charge cell phones or other electronic devices. The potential of this project is super hopeful, even though the process is a little slow. Geothermal heat. Below the surface of Earth is an abundance of geothermal heat energy. Scientists have been exploring geothermal techniques to harness some of the Earth's natural heat. There's a new technique being studied and used called enhanced geothermal system. This technique differs from the traditional form of geothermal techniques in that it doesn't need aquifers. Below the crust of the Earth, there's an abundance of thermal energy that if we can tap into it, it could supply a tremendous amount of our energy supply for the world, even if just a fraction of it's actually used. It is estimated that just the upper 10 kilometers of Earth crust has around 1.3 times 10 to the 27th power joules, which means that for the next 200 million years, it can supply the world's energy needs, which is amazing. That's a lot of thermal energy and for a very long time. To be able to use some of this stored heat or to be able to gather it, we need to use a geothermal technique. There already are some geothermal techniques that use hydrogen aquifers to tap into it. But with the Enhanced Geothermal System, or EGS, it's a newer type of technique and it doesn't require aquifers. This technique creates artificial fractures in impermeable hydrothermally heated rocks by injecting cold fluid, which is usually water. Then, when the steam that is produced gets used just as conventional geothermal plants do to produce electricity. With EGS, there's a possibility to harness a greater amount of geothermal energy, and it is a much more efficient technique. This technique is still being studied, but the potential is amazing. There are already several different EGS sites around the world with multiple countries, usually in the larger ones. The United States actually had the first EGS plant in New Mexico a few years ago, and that's the only one that we have as of now. But other countries, including the US, are looking to expand their operations by 2020. With these type of expansion, it could mean a greater supply of geothermal energy as well as a new clean energy source. Geothermal heat continued. This technique produces steam that leads to electricity, the way I said earlier, different than the traditional technique does. And there's a greater potential for supply as well as efficiency with this technique. And like I said, multiple countries, including the US, have already started their facilities around the world and are working to get those online. Here's a little collage of a couple of different of what I just talked about. The first one's a hand with a light bulb in it. That goes back to the grad student I was telling you about, who is talking about harnessing heat from our bodies to power electrical devices. The top left corner is actually a site, an EGS site. That's what one would generally look like, with the drill out there and a little compound set up around it. And then the top right is a picture of the geothermal resources of the United States and different locations of different hydrothermal sites and facilities for EGS. Thermal heat conversion. Thermal heat is one type of energy that is largely wasted every day. Harnessing this type of energy has become the focus of many scientists. Student scientists from MIT and Stanford University have been working on a device that can harness that energy to charge batteries. The batteries can then be used to power other devices. As I was discussing earlier, there's a large amount of low-grade energy, like thermal heat, that is given off every day and is generally wasted, especially by big power plants and big manufacturers. Because there's such a large amount of this wasted energy, a lot of scientists have become intrigued by it and have started to research different techniques to harness and to use this that's going to be beneficial to mankind. And some scientists at Stanford and MIT have come up with a technique that takes low temperature waste heat conversion and makes it into electricity. This technique revolves around a battery that goes through a 4-step process. Step 1 is heating up, step 2 is charging, then cooling down, and then discharging. The process is first started by heating a battery using waste heat and then applying a voltage to the warm battery. When the battery is done charging, it is then cooled, and because of the thermogalvanic effect, the voltage of the battery will then increase as the temperature decreases. And once the battery is completely cooled, it will have more electricity available to it than there was to actually charge the battery in the first place. The main purpose of this technique is to harness some of the waste heat that's generally at temperatures below 100 degrees Celsius. One scientist from MIT said that 1/3 of all energy consumption in the United States ends up as low-grade heat, which is a big amount. That being said, that if this technique actually comes to fruition and works, that could mean that there's a major boost in our harnessing of lost heat energy that can be converted into useful energy that can power just some aspects of our life. Volcanic geothermal energy. Similar to the idea of harnessing geothermal heat for energy, there is another technique scientists are trying using volcanoes. Volcanoes and the area around them are full of geothermal heat that is just sitting there. Some countries with high volcanic activity have already started research into this idea. This technique differs from the previous one that I discussed based on its production of heat. Since the need for energy across our world is so high right now, different scientists are looking to make for cleaner and more renewable resources to supply our demand. One idea that some of the scientists are studying is to harness the heat energy from volcanoes. Although not every country is located around a high volcanic area, some countries are. For instance, one that is a big one right now is Iceland. Iceland is actually very small, but it actually gets around 13% of its electricity from tapping into geothermal energy from the molten volcanoes present throughout the land. Starting in 2016, some scientists started a deep drilling project into the volcano system, one that had been laid dormant for over 700 years. During this drilling, they went down 3 miles into the volcanic rock, and there the temperatures were around 800 degrees Fahrenheit. And this type of technique differs a little bit from the conventional geothermal energy techniques that we talked about because it derives its heat from supercritical water. Now, supercritical water produces energy that is higher than that of steam produced from conventional geothermal steam. This supercritical water vapor occurs when molten rock and water combine and there's extreme pressure and heat. And because this supercritical water is not a liquid or a gas, it produces more energy than just steam does. And it can make 10 times the power output of other geothermal sources. Other countries like Indonesia are also pouring resources and research into developing more volcanic geothermal energy, and Indonesia plans on expanding their geothermal energy sector by 500% by 2025. Indonesia uses fossil fuels to get 88% of their electricity. And if their research on this takes, that could mean they could be a world leader in clean energy, and they could generate about 7,200 megawatts of electricity per year. Conclusion. It is important for us to continue to find new forms of energy and new ways to harness it. Fossil fuels are limited, and we are running out of some of them. We need to come together as a whole and work together to fight this looming challenge. To combat this crisis that we have, we all need to bring our research together, even though different people come from different places and some areas have different geographical things such as volcanoes, like I said, in Iceland or Indonesia. With their research coming together with our technology in other places, this is a challenge that we can all come to fight together. This slide's another collage. At the top is the Icelandic deep drilling project, like I talked about, and just gives a little representation of kind of the process of it, and a little diagram of where they get the supercritical water and how it all kind of works. And then in the bottom left, the picture I just put it on there was an area that shows that some countries have more volcanic activity, and that places like that are very necessary and very critical in their research for this. And then the bottom right is kind of like a representation of the battery project that the students are working on to convert thermal heat into electricity. And this is my reference page, and my references continued. Thank you.